I've been having a play of late then with physical throttle control for trains. Um, and I think there's already one video that I posted, and in that one I kind of prototyped a bit and had a little play. And since then I've continued working on it, and I think made progress and learned some things and produced something that's potentially quite useful and easy to use. So here's how I got to this point. The LCD screen has just arrived, and this is a 20 by 04 LCD I2C screen. It cost about £8. The I2C is the serial thing. It just means it doesn't need many pins, and the four it needs are SDA, SCL, ground, and voltage. It needs 5 volts, so I've got it running off a 5-volt power supply. Well, while I've got it upside down, one thing to note, I got it all rigged up and I put a test script on it, and it didn't work. The screen lit up, but nothing happened. And so I was messing about with cables and trying different addresses and all that kind of thing. And then I suddenly remembered that these things have got a contrast setting on the back. It's that little screw there. And just out of curiosity, after I tried everything else, I tried turning that, and suddenly the contrast was set on the screen and it displayed properly. So to save anyone else any time, if it should work, if the screen's lit up and there are no words on it, try twisting that screw a bit until some words appear on the screen. I've modified my code. I've been playing with the screen, and there are really good libraries around it. I'll put links to the guides I used. I'd never used a screen before, so again, whenever I'm starting with something new, I just start with the basics. So copy and paste a sketch from the internet that just turns the screen on and sort of says hello world. Do that, because then I'll make sure everything's working, I've got the right connections, the screen works, all that kind of stuff, and then gradually start to introduce the bits I want into the sketch, or in this case kind of take the bits I wanted from the test sketch and add them into the sketch I had for the knobs. I've got a test ESP set up down here in my office. The knob box, as it's become affectionately known, is still up in the loft. But I'm testing the screen. I'm seeing how I can adapt the sketch that was running on the box upstairs to use a screen as well. Because I think a screen is pivotal. If you're using this thing, because I don't want it connected to a PC all the time. I don't want to be having to use that debug window. So if I'm actually using it properly as an independent device, it needs a screen, because I need to know what's happening as I turn these dials. So I'll give it a reboot just to show what happens at the start. It connects up to Wi-Fi, and then it tells me how many locos it's found in the roster. And that's really just its way of saying everything's all right. I've connected up to what I needed to connect up. I've got a Throttle connection, and I'm up and running. So this is test one. I've only got 3 knobs attached to it, which means I've only got 1 throttle, because there's a loco select wheel and a function select wheel, which I'll come on to later because I've added that into the sketch. So I'd start by, imagine this is kind of, and I've got a remote control of JMRI here as well, and I've got a class 37BR throttle open. Obviously the power's off because I don't want these things running around. That throttle's open, and it's currently at a speed somewhere around 40. So back down to here again, I'm going to hold in my select wheel, or select button, sorry, and the screen changes. It told me I've held in the button on throttle 1 and I need to select a loco, so I use this wheel to go through the locos that it's found, and let's go for that 37BR one. Release this, and it's telling me here that the address of the loco I've selected is 38 short. It's acquired it. That message stays on for about 5 seconds. And then it goes to what's the default status page. This is the page that will be on there most of the time. The idea of it is it would have a row for each throttle. Obviously, I might have 5 throttles and there's only 4 rows, so I've added some scrolling, because these 2 knobs, the function select and the loco select, don't really have a purpose. If this button isn't, if a throttle button isn't pressed in, then these wheels are free. So I've kind of adapted the code so that they can scroll. So you can sort of scroll down to the 5th one depending on where you are, and then scroll back up. But I haven't actually tested that yet because I haven't been up with a 5 loco box. Anyway, this is the default page. It told me when I acquired the loco, that that loco class 37BR had a DCC address of 38, and the reason why it did that was because this status page, there aren't enough columns in a row to display the name of the train, so I can only really use DCC addresses. I've got to be brief. So when I acquire the loco, it tells me what its address is. Just remind me what its address is, so that when I've got a screen full of stuff, I've got a cat in hell's chance of telling which loco's which by the DCC address. The one is just throttle 1, direction forward, and speed is 39, and it's picked that speed up when I attached it because this class 37 over here, got a camera on my head, so I find it hard to know what to point at, already had a speed of 39, whatever it was. So pick up my throttle now, and if I start turning it, I can increase the speed, and those increases are reflected if I look at the dial. Here it's going up and down as I turn clockwise and anti-clockwise. But I might want to turn the light on, and this is kind of the new bit. So again, hold in my throttle button because I want to change something, and it will tell me on the screen again that I've held in throttle 1, and it's saying now you can either change your loco by turning the other dial, or you can set a function. So if I start turning the function knob, let's go for function 0, which is usually the light, and turn it on by pressing the button. It'll tell me the function's set, and if I go over here, I can see the light is now on. And if I hold the button in, I can sort of do multiple functions, because I thought sometimes, I mean, I don't really use sound, but I guess you can have quite a lot of functions. And say I'm up near, it takes a while, especially with these awkward buttons, it takes a while to get up to, say, number 22. And if I press it, here we go, like this, then I've turned 22 on. But then if I turn the dial again, I stay up there. It doesn't start me from 1 again. If I go down to 22, it will tell me it's now on. I don't know if this goes as high as 22. Yes, it does, and I can see 22 is on there too. So I think as far as the software is concerned, I'm happy with this. If I release the button again, it goes straight back to the display page, status page. But I'm pretty happy with it as it is. I think it's time to build it into a new box. And the first thing I need to think about, if I'm going to build this thing into a second box, is power. How I'm going to power it, because I don't want the ESP to be tethered to the PC all the time through a USB cable, so it's got to have independent power. And with the first box, all I really did was, if it had its 5 volts of power, it was fine powering the 7 knobs. It could get away with that with its 3.3 volts, but it can't power a screen as well. So I've had to come up with a way of powering both the screen and the ESP independently, while separating the 5 volts and 3.3 volts, because the 3.3 volts are going out to these, and it will only accept 3.3 volts coming back from them. It doesn't like 5 volts, so I can't have everything on a 5 volt circuit. I need a 3.3 volt circuit and a 5 volt circuit, while at the same time just having one power supply. And the power wasn't really that hard to fathom. I'm a bit of a beginner with electronics, really, but kind of what I realised was that the ESP will take a 5 volt supply as its power. So I mean, that's pretty much what it was taking from the USB. So you just replace the USB with a 5 volt supply, and the screen wants 5 volt supply as well. And then the ESP has a 3.3 volt out, which is what goes to all of the knobs, so that they can supply 3.3 volts on the input pins, because that's the maximum that the ESP can comfortably take on an input pin. So I happen to have one of these PCA 9685 boards sat powered and not doing anything. It doesn't really have any servos attached to it. So that's given me a row of 5 volt pins. So I took, and it also has a shared ground, which is a good start point. So I took one of those 5 volt supplies into the screen, and I took another of those 5 volt supplies into the voltage in on this ESP. So therefore, although the ESP isn't powering the screen, the screen is being powered by the same supply that has a shared ground, and the SDA and SCL cables are going from this into there. So the two of them are happy and communicating, even though they're kind of well, supplied by the same power supply, I guess. So then you've still got the 3.3 volt and another ground available on the ESP. So that's gone into a breadboard for now, and that's kind of sharing power along a row down there. And all of the knobs are taking their power from that 3.3 volt that's shared on the breadboard. I can't take a breadboard up into the loft really, and using one of these PCA 9685 boards would be a bit of a waste. So I'm going to have to get the soldering iron out to permanently power this. So these ESPs don't have any screw holes in them, I don't think. Oh, there's a screw hole. But they seem very kind of inconvenient, because obviously you've got all the cables coming out on one side and you've got the Wi-Fi receiver on the other. And I don't really want to have this, I think this is the Wi-Fi receiver, kind of screwed hard to a piece of wood. So I don't want it to dangle either, because these I bought these cables and they all become a bit loose really quickly. So what I'm going to do is use this because it's got nice screw holes and it mounts the ESP really well. It means I'm going to have to do a bit of different cabling because the inputs transfer to the screwy ones, but I'll at least be able to screw this board underneath the knob box itself, and it'll be permanently fixed and won't be dangling around. And the slightly modified power supply there, and I've made these before, they're just, is this prototype board? I don't quite know what it's called, but just stick a load of pins in, got 3 rows of them in there, and then solder them in on the bottom and just solder a wire across all of them for continuity. I've continuity tested all of it. And then the idea is this is the 5 volt input, so one for input, one for the screen, one for the ESP and a few spares, run of grounds along the middle, and then the 3.3 volt shared on the bottom. And this is small enough to just screw into the kind of the inside leg of the knob box and keep itself out of the way, but fixed and steady. I need to think about size too, because the last one was just based on a folded sheet of A4 paper, so probably A5 is that. And these are the two things that I need to add really this time. I've got the screen, and it's really, the screen looks too wide here to have comfortably have a knob either side if I'm still going to have the sort of the bracing down the side. And I'd really like to be able to screw one of these to the bottom. They would fit, but there's no room for knobs. Here's knob box Mark II then. Very scruffily painted and dreadful jigsaw work around the screen, but nevertheless it is knob box Mark II. And underneath I've got everything in, so that's the back of the screen. This is the ESP in its little harness so that it's stable and not dangling. And here are all the knobs, obligatory paint spill, and the little run of pins for power down here. Down in this bottom left hand corner, sometimes you've got to be careful with labelling there, because I'm coming to connect power to this thing now. Down here, second up, you've got your 5 volts at the bottom, and second up, if the camera's picking that up, they've got GND, which indicates ground. Now that surprised me, because there isn't a ground there on this. The ground is a bit further up. And I went and had a look. I've got pictures that I use for reference because my eyesight isn't really good enough to see this stuff. But actually, the next pin up from 5 volts on here, according to the images I've got, is I think GPIO 11, which is labelled CMD. Now I don't know what CMD is, command, whatever it is, but that's not ground, that's not GND. So they made a mistake down here, and I don't want to be connecting a ground cable to GPIO 11. Very basic power setup here just to make sure that it's all working. I've got 5 volts again coming from this little PWM module here into the little 5 volt run on this set of pins and ground into ground. Then there's another 5 volts coming out powering the ESP, another 5 volt feed coming out there and feeding the screen, and then the SCL and SDA connections coming down to the SCL and SDA connections on the ESP. And so really that's just, if I turn it over, that's just to establish that I've got the screen in the right way around, because it would be quite predictable that I got it upside down. Here's box version 2 then, hopefully wired up and ready to go. I've got the ESP in its little harness there, screen fixed up there, all the knobs fixed on. There's a 5-volt power supply just coming from down below to there, which is going into here, into the shared ground, into the 5-volt. The 5-volt then comes out and powers both the ESP and the screen. Then the ESP has the 3.3 volt coming out, going into a line that's just on the bottom. There's 3 rows of pins on there. And then, so the 3.3 volt goes into there. The ground's already shared because it's already connected there, and all of the knobs are getting their 3 volt supply from the shared row coming from the ESP. I've still got absolutely no idea where it's actually going to go. If it gets, I think it probably will get a permanent home, but I don't know where that's going to be yet. But wherever it is, I think it needs to be angled towards me. I don't know if this camera will pick it up, but with it flat, it's really quite hard to see the screen. So it's going to need, wherever it ends up, angling towards me just to make the screen a little bit clearer. I don't know how well the phone's picking that up, but it reads quite clearly to me where I'm stood. It's time, I think, then to have a little play with trains. So I've got the latest iteration of the box up here. I think it's probably worth pointing out at this point that the more I've tested it, the more useful I've thought it's going to be, and the more likely I've thought it's going to be that the thing is actually going to live on the layout and be used. So there have been a few little additions, like little bits of functionality that I thought would be useful to something that I was using on my layout, but I'll kind of go through those. So general idea is you've got the 5 knobs here, and these are your throttles. So 5 knobs, you can control 5 trains. Status page up here, that's how it is when it's turned on. It's just kind of telling you it's ready. The first thing I've added is track power, because it's quite useful to have from here. So if I press this button down, it will turn the track power on. Next thing to do, I've got a few trains kind of around here and lined up. So that's Swallow. I'm going to grab hold of the 47 Swallow. Again, I've kind of gone through this, but it's I like how the train names appear on the screen, and then it's telling me what its address is, so that when after 5 seconds we go to the status page, I can see up there on throttle number 1 I've now got DCC address 47, which I know is the Swallow class 47, direction forward, speed 0, and then up in the corner here I've just got this power indicator, so I know track power's on. So let's get this moving. Obviously just turn its assigned knob to get it moving, get to 30, that's fine. Then got class 43 here, so let's do the same for that. Again, hold the button in that I want to actually drive the train with, go find the train, which is, I just pass it, that one, yeah, let go again. This will add it to line 2 of the status page after that little 5-second timeout again. There we go. I've got address 28 on number 2, and let's get that up to about 30 as well, get that going. Somewhere around the back I've got an APT on this upper deck as well, so let's get that on to number 3, and I'll know that's moving because it will squeak. Always know when the APT's moving. Yeah, that's definitely on its way. And then I've still got 2 left, so I've got 2 sort of planted on the bottom deck. There's a little 101 here, so I'll go grab that, put it on number 4. That was that one. And now, of course, I've run out of lines, so that's started moving away. But I've got another class 101 sat ready to go on the clockwise line downstairs. But the problem is, of course, I've got 5 buttons but 4 lines. So first thing I do is get the train going, or at least assign it to that throttle, and that's class 101. And now, of course, the issue is I've only got 4 lines, but I've got 5 throttles. So on this knob, I added a little scroll button. So if I turn it once, instead of being from 1 to 4, it'll go from 2 to 5, and I can see my little 101 down there and set that off at a decent pace as well. And then at any point, I can scroll back up so I can see 1 to 4. I've also added, just because I've now got 5 DCC addresses to remember, and I'm never very good at that. So if I forget what number 35 is or what number 104 is, whatever that, if I turn this one while everything's running, it will scroll through all of the current, all of the throttles and what's currently assigned to them. So I can go through and I can see that whatever, you know, what it was, address 35 is the APT. And again, leave that, it'll time out after 5 seconds and go back to this status page. And I mean, really, that's it. You know, five trains running. I can always, if I get one parked, that 101's just kind of safe. If I let that, was that on number? See, that's on number 4. So let that get down to the bottom. One button press will stop the train and set it to speed 0, and then I can either go back in and pick another train to drive, or if I let go, it'll release it and kind of note it down as unassigned in the list, so I can come back. It's a good idea to unassign them, I think, because if not, I do get the knobs mixed up. I'll end up driving something that's parked and into a short or a derailment, so it's useful to release them once I've finished driving them. The other thing I have, the one last button press that I got open to me was this one, which I thought would be good as an emergency stop. So press that and all the trains get sent to speed 0, and I can then turn the power back off if I want.
I'm certainly not going to go through all this code line by line, but I think it's probably not fair to have got this far and show all the electrical stuff without sharing the code as well. Big caveat, the code's still a complete mess. I started out, the thing's still called knob test because it's still the code that started out as just seeing if I could detect the movement of knobs. So it is a big mess. At some point I will tidy it up, but for the time being, I'm just going to share it as it is because it kind of works. And maybe do a few pointers towards the bits that anyone who wanted to use this code would need to think about to make it work with their layout. So the first thing is up here. There's a roster entry. This is the list of trains. Now I set this array to 30 because I know it's only going to get about 22 trains. So always set that value to something slightly higher than the number of trains that it's going to download from WiThrottle and be able to drive. Number of throttles up here, so that needs to be, that's the number of knobs you've got connected to the ESP. And here is where we determine the knobs and which pins they're connected to. Now, certain advice here would be to certainly not use, if you're using an ESP, not use any more than 7 knobs, because there simply, on the one I've done, there simply isn't a spare pin left. So I'd also I definitely recommend using both a selector and a function selector. Not sure how well this would work if you didn't have a function selector plugged in. You would certainly need to comment out all of these function selector instantiation lines and all of the subsequent references to it. And these are your pins. So this uses the controller class, and this uses pins 34, 39, 36. If you've got the controller class, you can see that that's encoder A, encoder B, and encoder button. And up here, that's the CLK. These are the actual labels on the knob: CLK, DT, and SW. And if I just grab an image, what I've tended to do is kind of work around clusters of pins together. I would also advise using all these pins, because I don't think there's a single other pin on that board that, if you use it, doesn't interfere with something else the ESP wants to do, like boot up or anything like that. So take the selector, that's 34, 39, 36. And if I drag this over here, that's just a little cluster of them there. And again, it just works through and uses all of the pins in this list here that are actually available and usable. There is obviously all the LCD stuff. If anyone isn't using a screen, just get rid of all of that. Standard Wi-Fi stuff, copy and pasted from another thread. Sorry, another sketch. Needs Wi-Fi, obviously, because it has to talk to WiThrottle. There's a big void at the bottom. I've just moved this out the way and put it in a separate function because it was a great big mess at the top of the loop. But that's all the stuff that checks to see if there's any data coming in from WeThrottle, like changes to direction or speed done by other throttles using the same loco, or it reads a lot. It reads all of the stuff about the roster in when it loads. I didn't realize, someone left a comment on the first video that there's a WeThrottle library for Arduino. I didn't know there was, so I've just written this kind of raw. So all of the communication with WeThrottle, whether that's sending updates to speed to actually drive trains or whatever, is done pretty raw with the TCP connection and just using the WeThrottle protocol, which to be honest is fairly simple. There's also somewhere up here, there's a thing where it tells I can't remember where it is now, but it tells WeThrottle what its name is. I can't remember, I call it knob box or something, but there's a line somewhere that does that. Oh, there it is. So if you want to change the name of the box, then just change that bit there. And really, that's it. The rest of it is just checking for movement, and there's all this stuff it does. If it detects movement, I put a lot of debugging because I had to do a lot of debugging. So there is a lot of stuff that sort of tells you. It sort of acts as comments because it was sending debug information to me. All these write strings, these are where it's writing stuff to WeThrottle. So this is where it's sending instructions. That's power that it's sending there. Um, and yeah, I mean the rest it would take a long time to explain. All this confirm message stuff. This is all stuff that's going to the LCD screen, and then there are a few methods down at the bottom, like write string. Oh, write string is what it writes to the Wi-Fi client. So this is where it's writing to the WeThrottle. So all changes to speed and all that kind of stuff. And the rest of these methods down here are all just about using the screen, printing lines to the screen, because it was a bit awkward to use because you've got to make sure you clear everything on there before you write the next thing. So there's where it's writing the status page, which took quite a bit of stuff in the end. Updating the speed on the LCD, displaying a timeout message as well, those ones that last 5 seconds. You'll see there's a lot of 5,000s around where I kind of uh, freeze the screen for usually for about 5 seconds. So this is still that's where it writes the summary page when you scroll through using the right hand knob, and then all this stuff at the bottom. Read from WeThrottle, which hasn't quite pasted properly. Is where it's collecting up data that it receives. That's not comprehensive. WeThrottle does send a lot more data than this thing collects, but it only, as far as I'm concerned, I'm only interested in collecting the stuff I use, which is speed, direction, functions, and the roster itself. And just a brief word then on the knob rotation. This diagram sort of shows how this reflects, as best as I can describe, how it feels when you turn the knob. It kind of goes up slightly, then it goes down slightly. So you're going clockwise like that. Now each of these counts as an increase. So you kind of, you've got an increase of 1 here and an increase of 2 here. But as you turn the knob, you kind of it naturally wants to fall into these low positions here. So this is fine. Just natural usage is fine for, say, the speed increases, because you kind of got to increase of 2, 4, 6, 8, and that's kind of enough granularity. When you go into a speed of 100 or whatever it is, that's enough. But for the loco selector, this didn't feel right, because if you wanted to select a loco that was on an odd number, you kind of had to almost balance the knob on the top bit when it really wanted to fall into the bottom, and it felt unnatural, and it felt like you scrolled through the locos too quickly. So I tried to modify it so that it only increased when it settled in a groove here, rather than when it was up there. And I did that here. I think I'm just pointing out because that's there's no comment on here, and it would take too long to comment. So it uses the old mod maths thing. So it divides the increase by 2 and keeps the remainder. So if it's an even number on those bottom things, 2468, then the increase will always be 0. Or if it's up on one of the top ones, the increase will be 1. And it only acts if the increase is 0. That increase is the wrong word, I think. There is kind of difference, because that's not actually what it uses. But I just yeah, thought it's important to point that out, because it's hidden in there, but it does quite a lot. And one more line that I forgot, that's quite important, is this one down here. When you connect to Wi-Fi, this needs to be the IP address and port of your Throttle server.
This is where I tend to navigate to control trains. It's where the keyboard and mouse are, so the monitors are there, so there's a lot of point control happens with the mouse keyboard. There's routes there as well, and so a natural place for a fixed throttle system to be is around there too. It probably can't stay there. There'll end up being hopefully some kind of scenery there, so I'm gonna have to find somewhere around here to permanently fix it, which I haven't worked out yet, but definitely useful, definitely quite a lot more enjoyable to use. I mean, the tablets will still have their use. It's still very handy if I'm going to look at a derailment or whatever it is. It's very handy to be able to take a tablet with me to the other end of the loft, so that I've got control over there. Or if I'm trying to work out why a turnout's not turning, to take the tablet with me so I can, perform the action and be right over the thing that's not working. But I think for general sort of day-to-day playing with trains, I think that thing really works, and it's the first thing I make my way to now, once I'm up here and actually want to get trains moving.